Hello everyone. Today's class I would like to introduce new concept electricity. So we know the early basics of at least about switch and bulb and cell or battery and connecting wire. Now whenever we think about electricity, first what we saw, which is outside, a bunch of wires which are connected from far away distance. So through these wires to our house we are able to get electricity, and inside our house we were connected with these wires. And you know, these wires are made up of metals. One is outside, which is made up of aluminium. So this wire is made up of copper. So aluminium and copper are metals, and metals have the properties to conduct electricity. And we know the metals good conductors for heat and electricity. Metals are the very good conductors to heat and electricity also. And here you see closely, so this copper wire is coated with or insulated with rubber. So this red materials or black, which is outside, so this is called insulation. And rubber is good insulator. It means current do not flow through rubber and current flow through metals like copper and aluminium. So what really this copper and aluminium contains? So these wires really contains elements which are made up of atoms. Yeah, copper is made up of copper atoms and aluminum is made up of aluminum atoms. And we know that a minimum knowledge about atom. And let us think about what is inside an atom. So an atom is a fundamental unit of matter. An atom is made up of protons, neutrons and electrons. And here protons having mass and they are having charge. Proton having positive charge and electrons having negative charge, and neutrons, they do not have any charge. So charge is a fundamental property like mass, the mass and charge. So these two are the fundamental property. Atoms contains protons, neutrons and electrons. Proton having mass as a fundamental property and having positive charge. And electron also having mass and having charge as a property. And neutrons, very very important. Neutrons, they have only mass but they do not have charge. So to describe electricity, so we need to know about these electrons. So everything is made up of atoms and which contains positive particles called protons and negative particles called electrons. And we know the early knowledge of atomic models. In our previous classes we studied about different atomic model like Rutherford atomic model and Bohr atomic model and Thomson-Pompidou model. So those models are explains where is the location of protons and where is the location of the electrons inside an atom. So as per Rutherford and Bohr atomic model, the protons and neutrons, they both are inside the atom, which is known as nucleus, and electrons are revolving around the nucleus. So again, atom contains nucleus. Nucleus contains only proton and neutron. So they are fixed, they are inside nucleus. And electron are revolving in orbits. So in atoms, electrons only free, they only can move. So if we make electrons move, so that is the cause to get the current. So an atom will usually have the same number of protons and same number of electrons. So then we can say the atom is neutral. And sometimes if we can remove the electrons and we can add the electrons. We can only remove an electron and we can add an electrons. But we cannot remove nucleus. So if an atom contains equal number of positive charges and equal number of negative charges, then we can say that atom is electrically neutral. So all about we need to know much about electric charge. So electric charge is given by symbol capital Q, and electrons are the charge carriers that flow in an electric circuit. So in a given circuit, electrons only will flow from negative terminal to positive terminal. So that I will make you understand what is negative terminal and what is positive terminal. And charge is measured in units of coulomb, and we represent that coulomb as unit capital C. And charge of a proton, we are having a quantity, the amount of charge of a proton equal to 1.6 times 10 power minus 19 coulomb, and which is the same size as the charge of an electron. Electron charge and proton charge, magnitude or amount, they both are same. But only thing is that electron having negative charge. We can put negative sign while we are writing the electron charge. So it is something, suppose if I write the charge of electron, so electron charge which equal to minus 1.6 times 10 power minus 19 coulomb. But always we will represent the magnitude only. So whenever you can say charge of an electron, so that obviously it gives negative. But charge of a proton, so it obviously comes with positive. Separately we don't mention the negative sign for an electron. Electron charge always comes with a negative. Now if you define electricity have a negative charge, so that measures in coulombs. So electrons have negative charge which is represented with capital Q, and it is measured in coulombs. And electrons move around a circuit from negative to positive. That gives rise to an electric current. Let's see the diagram it here. How electrons move causes current. Now I am having here wires. So we know that right now these wires contains electrons. So these are the connecting wires. What these wires? These wires contains electrons. How these electrons will move? To move electrons we need this known as source or battery. Now battery is connected to wires, and that wire is connected to an electric bulb through a switch. So when we on switch, means the circuit gets closed. So that is the use of switch. When you on switch, the circuit gets closed, and electrons which are present in the wires. Electrons which are present in the wires, they will move from negative side of the battery to the positive side of the battery. Now when electrons is moving, so it carries charge. That charge is used by bulb. The electric bulb uses charge which is carried by the electron. Now how the electrons move? To move the electrons we need very important. So that is battery or source. Let us understand this with the help of a simulation. So here I would like to construct an electric circuit, a simple electric circuit. So for that I have taken an electric bulb, and so this is my source which is known as battery, and here very important things, we need wires, connecting wire. So this connecting wire, let me quickly connect these wires as like this. Now the cell is having two terminals, one is positive, one is negative. So I connected negative terminal to wires to a bulb, and the another end also we need to connect. And the circuit is always closed. Now here I would like to introduce switch also, so that we can understand. Yeah. Now my circuit connection is complete. Now here mentioned, so this is bulb and this is source, I can call it's a battery, and this thing is switch, and the rest of things I connected with wires. Now here what you are seeing, the blue, just like the blue dots you are seeing, so those are electrons in the metal wires. Everywhere they are they moving? No. Why they are not moving? So because the switch is here, the switch is not connected, so this we can say off. Now the switch is in off position, I did not connect switch. Now suppose if I connect switch, now here you can see something is moving. So here the moving, these things are nothing but these are electrons. So electrons are moving in this closed circuit, all the way they are moving. So when switch is connected, so that causes electrons to move. Now why the electrons are moving? So because of this battery. So battery pushes the electrons. That is a different concept, we can talk when the situation comes. When electrons are moving, and here you can see the direction of electrons, from which direction they are moving. So they are moving, suppose if we take from cell negative, so this is a cell positive, so they are moving from negative to the positive, or if you can take this is clockwise direction. Electrons are moving in the circuit clockwise direction. So when the electrons are moving, so that causes current. So that we define as current. So how we define as current? The rate of flow of charge. Suppose if I disconnect again at here, now the electrons, they stop to move. Electrons are not flowing or not moving. Even the cell is connected, the wires they are having electrons, but still electrons are not moving. Why? Because the circuit is disconnected. Switch is open. When switch is on means switch is closed. So the source, the battery, will push us the electron from negative terminal to positive terminal. So that causes the bulb to glow. So that's the reason here we are getting light from the electric bulb. Now here we define current. Current can define as the flow of charge. Flow means motion. The flow of electrons. The flow of electrons we define as current. So we can define that current I equal to Q by T. So here Q is the charge of an electron, T is the time. So this is how we define electric current. So according to definition, we can define that in different way, but as per understanding, you can remember this. Current is nothing but the flow of electrons. When electron flow stops, there is no current. Here there is no current, there is no light. So to get the light, what we need to do? Again, we make them to flow. Who need to flow? Electrons need to flow. So when electrons flows, then only it contributes current in the circuit. So finally, to glow bulb, the electrons which are present in the wire, so they have to move from the negative terminal of the battery to the positive terminal of the battery. Now here one question. We divided the substance in conductors and insulators. So here you can identify certain conductors and certain insulators. So conductors, they are having good number of electrons, so they can conduct electricity. They are having more number of charge carriers like copper, aluminum, mercury, all this. And insulators, they do not have any electrons. They do not have any free charge carriers like glass, wood. So these and rubber. So these are the insulators. So insulators, they won't conduct electricity. And what makes something a good conductor? Good conductors allow electrons to move through them easily. So that's the reason this copper and aluminum and gold, silver, all metals, so these are the good conductors for electricity, because they are having free number of electrons more. And insulators, they do not allow electrons to move freely. So in conductors, electrons move freely, and insulators, so the electrons, even the electrons are present, but they cannot move free. What could be the reason? That we can understand in the next concept. So finally, I can define electricity. So electricity defined is like that: the movement of charge around a closed circuit, around a circuit. So we call this as electric current. So how electrons flows? Just like if you can take a candle, you can put a metal rod, how heat is flowing from one end to another end. So here the heat is carried by the electrons. In this example, the heat is carried by the electrons. I can represent electrons with E minus. The electrons will carry heat from one end to another end, because in this metal, electrons only move. Electrons only move because they are outside the nucleus. They only move. So inside the atom, nucleus, it cannot move. So when electrons, So they take the energy from the flame and they pass one to another like that, and it will end up to we can get the burn. So this is how heat is flowing from one end to another end. Likely how the current is flowing. So current is also flowing from one electron to another electrons because of this source. So the source causes to move the electron which are present in the wires. So when electrons move, it carries charge. Now that charge is used by bulb and the bulb starts to burn. So here how the electrons move through a wire in a closed circuit. So the arrow shows the direction of the electrons which is moving. Electrons moves always from negative to positive terminal of the cell. So that is the direction of the electrons. And we can define current with a symbol I. The current is the movement of negative charge in a circuit, or the flow of electrons in a circuit is defined as electric current. It is represented with capital I. So current is a amount of charge flowing per second and is given by the unit ampere. And if the current is charge flowing per second, we can define I equal to Q by T. So this is formula for current. So here I we measure in terms of amperes, and charge we measure in terms of coulombs, and time we measure in terms of seconds. So 1 ampere equal to 1 coulomb per 1 second. So if 1 coulomb of charge is flowing in a 1 second in a given circuit, then we can define that as 1 ampere current is flowing through the circuit. So this is the formula we will use to find the current which relates charge and the with respect to time. So finally I define current as the movement of charge electrons, or the rate of flow of charge. So this is final definition I can give. The rate of flow of charge, the rate of flow of your charge is electron, is defined as current. Rate means in physics time. Rate we will give the word to time. So the rate of flow of electrons is defined as current through a given area.